Okay. So to avoid the mistake, you follow the steps. So it will be better to have the solution. Okay. So now what we'll do, we will take h equal to, here in this case, 0.1. So we are going to follow 3 steps. So first you have to write my x0 is 0, y0 is 1, and my x2 will be x0 plus h. So that will be 0.1. I don't know what is the y2. So this is what I am trying to find out. So therefore, I write the formula y1 is equal to y0 plus h into f of x1. So my y1 will be equal to, my initial y0 is 1 plus h is 0.1 and f of xy, which is x square plus y. So x is 0 plus y is 1. So I am going to get 1. Okay. So that gives me 1.1. This is what I will have as a y1. Now next step what I do, I rewrite this again. x0 is equal to, now this becomes x0. x0 is equal to 0.1. y0, I recently got it, is equal to 1.1. And now x2 will be equal to x1, x0 plus h. So x0 is 0.1, so I need to add h, so it is 0.2. And what will be my y2? Again I write the same thing, y1 equal to y0 plus h into f of xy. My y1 is equal to y0 here in this case 1.1, h is 0.1, and it is x square. So x is 0.1 square plus y. Y0 is my y 1.1. Okay, and this is what gives me a value. Okay, so just give me this value. What is this value, please? Yeah, I got the one answer. Yeah. So 1.211. So this is what's the value I got it. So now again I write it. My x0 will be 0.2. Okay. And my y0 will be 1.211. And my x1 will be now 0.3. And I need to find what is the value of y1. So here at this location we are going to stop because x1 is 0.3. Okay, so that we have to find out y of 0.3. So here in this case we have to stop now. This is my last step what I am going to do. If you do not write in this way, what is going to happen? that you will end up in finding either one value before the requirement, or you will go ahead and find out the future value, one value. So you will not stop exactly at whatever at the location at point 3. Okay. So that is why these steps are very essential. So it ensures that you are stopping at the correct location and you are providing the correct value. So again I write y1 equal to y0 so my y0 is 1.211 plus h is 0.1, x square is 0.2 square plus y1, that is 1.211. Okay, so get me this value. Anybody else has got this value?
Sir, at point 1 it should be 0.3, no?
Yeah. बोल.
No, sir, got it.
Okay, so I am getting 1.3361. Okay, so this is what I can say y of 0.3 is 1.3361. So if try to follow these steps, so you will end up in a you will end up at the correct location basically. So if you will not follow, either you will end up at this or one value ahead of this. So that gives you incorrect result. Okay, and your option whatever is available to select it, so that will not be correct. So to ensure that you are stopping at this location, follow these steps. Okay, so if you have any question related to this, you can ask, or else you can type U, that you have understood the Euler's method. If you have understood, you can type U, or else if you have a question, you can ask. Okay. So in transfer, basically, there are a lot of applications, especially transient analysis. So just give me a time, I'm trying to find one application. Okay. I hope you are able to see the Chrome browser. Anybody could answer? Hello, can you see my browser?
Yes, sir.
Okay. So let's try to solve this problem. So you can provide your equation here. Okay. Now enter x0 is 0, enter y0 is 0, and we have to find x equal to 1 by taking a step size of 0.25. So my xn is 1 and number of division I would like to make a 4 because the step size is 0.25. From 0 to 1 I have to reach with the step of 0.5. So my number of division has to be 4. That is what is its meaning. So if I hit solve, you could see the x is varying correctly in a step of 0.25. So you have x0 0, x1 0.25, x2 0.5, and x3 0.75, and the x1 to be 1. And here in this case I am getting a corresponding values. So I have the 0, 0. So these are the corresponding y values. Similarly, I can could get the comparative result. So I can say this value is less accurate than this value, than this value. So RK fourth order method will be having a higher accuracy, and that is why these two separate graph has been plotted. Euler's method somewhere here and RK2 and RK4 here, because they are comparable. RK2 and RK4 are comparable and not the Euler. So Euler will have a some sufficient amount of error for larger value of h, because we are neglecting a lot of terms in the Taylor series method. Okay. So RK2, RK4 will be having a similar sort of accuracy. Naturally, RK4 will be having a better accuracy than the RK2, that is Runge-Gupta second order method and Runge-Gupta fourth order method. Okay, so you can use this simulation tool to solve the problems. So there are various problems given 1, 2, 3 and 3. So this is the application based problem. You could try to solve what you are trying to get it. and try to find out the solution and try to compare what is happening. Okay. So now let's move to the next method, that is the RK2 method. Okay. So this method is not in your syllabus. Directly RK4 method is there for first order differential equation. But RK2 method in any way you have to study to solve higher order differential equations. So we are presently solving a first order differential equation. If we have to solve second order differential equation, we have to study RK2 in any way. Okay, so therefore we will be starting with the RK2 method. Okay, so again this is my solution. So this is my initial value of x0, this is value of y0, and this is basically y is equal to phi of x. Okay, and I need to find out this value, that is x1 and corresponding y1. So here in this case, what actually we do it? So first we draw the tangent. That tangent will intersect at this location. So slope of this is represented by s1. So it is the equivalent slope. Equivalent slope is represented by s1. And now at this point to this curve, I will also draw a tangent. So this is the slope s2. So I have the two slope variation, and I will take the weighted average of these two slopes. So my weighted average S will be is equal to S1 plus S2 by 2. So whatever the average is going to come, with that average I am going to draw a line from this location which will intersect somewhere here, and this is my value of y1. So previously if I have a S1, this could be my value of y1. Okay, and I use the S2 slope at this location, take the average, draw the line again, I will reach the value of this y1. So you could see there is an improvement in the accuracy. Now this is S. It is the average of S1 plus S2. Okay, this is the way what we do it. And with this average, I get the value of y1. So I could write S1 as, so it's the equivalent slope h of x0 y0. Okay, and slope s2 is at another point, so I can write h into f of x0 plus h and y0 plus s1. Okay, so y0 plus s1 is what the value, next value. So I could call this as a x1 and I can call this as a y1. So if you remember what is y1, y1 is y0 plus h into f of x0 y0, and I could call this as a s1. So this is what is there, s1 I have seen written. So I could write y0 plus s1, so that is y1. So generally we use term, we do not use this x1 and y1 variable, we use x0 plus h, y0 plus s1. And finally I do calculate my s is equal to s1 plus s2 divided by 2, and my next value of y1 will be y0 plus s. So these are the steps 1, 2, 3 and 4 steps we need to follow to get the solution. Okay, so if you have understood this, you can type R, or if you have the question you can ask. Okay. So let's solve some problem with the help of this. So dy by dx is equal to, let us say now, x plus y square with initial condition. Let us say x equal to 1, y is equal to 0, and I would like to find y at x equal to 0.3. So this is what is I have to find out. Let's take, or let's assume h is equal to 0.1. So this is what we are trying to do it. So we will write x0 is equal to 1, y0 is equal to 0, x1 is equal to 1.1, and for that I am going to find the y. So here it is a 1.3, okay, not 0.3, because this is 1, we have to go ahead. You can go back also, that is not a question, but still, so 0.3 coming back means 7 steps will be required. So if you want to do it 3 steps, so we are moving ahead in future, so it's a 1.3. Okay, so at x equal to 1.3, what is the value of y? So let's write the formulation. Y1, not y1 now. So we have to find S1. S1 is equal to h into f of x0, y0. So h is my 0.1. Okay, we have taken h is equal to 0.1. F is my x plus y square. X is 1, y is 0 square. Okay, so I got 0.1. Now my S2 will be h into f of x0 plus h. H is 0.1, so I get 1.1. So I write the formula first. x0 plus h, y0 plus s1. So this gives me 0.1. So 1.1 square plus y0 is 0, s1 is my 0.1. So therefore 0.1 square. 0.1 not square, just 0.1. Okay, it is correct. So this is square, so it is y square. Okay, 1.1 plus 0.1 square. Okay, fine. So get me the value of S2. So I have 0.11. Okay, great. So now my S will be S1 plus S2 divided by 2. So this gives me 0.1 plus 0.11 0.11 divided by 2. Okay, so what is this value now? Yeah, 0.1055. So now I can write my y1 as y0 plus s. So my y0 is 0 and my S is 0.1055. So my Y1 value is 0.1055. Okay, so this is what is the value. Now I can write my X0 is 1.1 and Y0 is my 0.1055. My X1 will be 1.2, and for that I need to find out what is the value of Y1. So I will calculate S1 as H into F of X0 Y0, which will be equal to 0.1. It will be X, so 1.1 plus Y square, so 0.1055 square. Okay, so you can get the value of S1. So just let me know the value of S1. Okay. Now S2 will be H into F of X0 plus H and Y0 plus S1. So that will be 0.1. So this will be 1.2 plus. Now my Y0 is this one. So it is 0.1055 plus 0.111 square. Okay. Okay, so get this value. I got two different answers. Point 12469. Okay, so this is what is the value. Now I will get the S, that is S1 plus S2 by 2. Okay, so now get the value of S. So I have 0.117895, and therefore I could write Y1 as Y0 is 0.055 plus S, that is 0.117895. Okay, so get this value. 1.223395. Okay. Now my x0 will be 1.2. Okay. y0 is 0.223395, and my x1 will be 1.3, and what will be my y1? So here I have to stop. So now you will do all these steps and you will let me know value of y1. Start doing it. one answer we got it. Anybody else have got the answer? Anybody else got the answer? Yeah, so okay, all three answers are fairly close. Okay, so you can accept those answers, no issue. Now we'll focus on the program of the Euler's method. So programming on this topic is the most easiest one. So just let me know whether you are able to see my Visual Studio Code.
Yes, sir.
Yes, sir.
Okay. So this is the function which we'll be solving, that is x square plus y, x square plus y, this was the function which we will be returning. And what Euler's method require, it will require initial values, and it is a value, final value of xn. So y at 0.3, something like this we are interested in find out. So that will be a xn will be 0.3, and how many steps we have to do it. So if you want to do the 4 steps, so this is how we calculate the value of h. So in programming, just little different thing what we have to do it. So we take the number of steps to ensure that the correct procedure is followed. If you ask h to be entered, so it is likely that user might say this is 0.3 and value of h, if this is maybe say 1.2. So what happens here in this case? So there will have a mismatch of h value will happen, and your program will give you incorrect answer. So when he provides the value of xn, he needs to provide the suitable value of h. Okay, but it is likely that unsuitable value also gets provided. So to overcome this problem, we ask the number of steps to be required, and we calculate the h so that there will not be any kind of mistake while running this program. Okay, so this is how we do it. So the program is pretty simple. So this is y1. Okay. So I am getting a y1 is equal to y0 plus h into f of x0 y0. And now if you remember, what is the next step? Next step is this x1 will get replaced here. Okay. And whatever the y1 value you are getting, that is also get replaced here. So x1 get replaced to x0 and y1 get replaced to y0. Okay, so these are the two statements. I can do it in a one statement like this, which I have written. So I could say y0 changes to y1. So on right hand side it is a y1 value, and on left hand side it is a y0 value. So I am calculating, at the same time I am also replacing. This replaces the older value of x0, which becomes x0 means now x0 equal to x0 plus h. So on the right hand side it is x1. So we are calculating x1 and at the same time replacing the x0. So if you have understood these two lines, you can type 49, or else you can ask the question. You can ask the question if you haven't understood, or else you can type 49. Okay, so now what I do, I just copy paste this function. So I'm not going to debug the program. Okay, now it's your part. So I have written that if a error exists, you have to solve this. Okay, so I can call this as a RK2. Same input will be required. Same thing I will be doing, but here in this case I will be calculating first S1, S2, and then the rest thing. Okay, so this is my S1 and I need S2 also, which will be equal to H into f of x0 plus H and y0 plus S1. So this is my S2 which I am going to get it, and then I can calculate S. S is equal to S1 plus S2 divided by 2, and then I can calculate y0. So I don't need to write var here. This is y0 simple, because y0 we are taking as an input. So y0 is equal to y0 plus S. So this is the program for the RK2. It's a plain and pretty simple program. So if you run Euler function, so Euler program will run. If you run RK2 function, the RK2 program will run. Okay, so input requirement for both is same, so we don't have to change the input. Okay, so it's pretty simple programming on a differential equation. Okay, so there is not a much deal. So try to write this program on your own and try to debug this. Okay, so finally you can type U if you have understood RK2, or you can ask the question. You can type U if you have understood RK2 method. Okay, so now whatever the error is coming, now you try to debug it on your own and try to see and try to make this run happening. Okay, so soon I'll be posting all the rest of the assignment. Okay, so there was a certain problem in my Google account, because of which I would not be able to create a say new assignment. Okay, so now it's done resolved, so I'll put it today or tomorrow, all the assignments. Okay, thank you, can start leaving. One important thing, I am having the next lecture at 10:15 today itself. So I'll be going to college now, and then I'll be conducting the next lecture. Okay, but if I could not start at 10:15, I'll be starting at 10:30. Okay, so on the it is likely that I will be traveling, so I may not be able to put the message while traveling. So if you don't see the meeting starting at 10:15, you can join at 10:30. Okay, most probably I will reach at 10:15. Thank you, you can start leaving now.